We have a quadratic function with a vertex of 4, -7, and a positive leading coefficient. And what we're going to do is we are going to use that information to solve all of these. So I don't know anything else about this. All I do know is it's a quadratic function, and a quadratic function with a positive leading coefficient opens up, and then if we have a vertex of 4, -7, that could be some point here in the fourth quadrant, and I know this is going up. So this is all I know so far, and I know that this is 4, -7. So this draw a sketch to help visualize the graph, that's going to become really helpful. All right. So here we know the graph opens up. And again, the reason why we know it opens up is because it has a positive leading coefficient. A negative leading coefficient is going to reflect it over the x-axis, and we did not have that, so it's definitely up. The axis of symmetry is always x equals, so it's an equation for a vertical line, x equals the h value of the vertex, so x equals 4, so that's this guy here. And then our range, all right, because we're opening up, if you are looking for range, remember we're going from the bottom to the top, so our first y value that exists is -7, and then we go to infinity. And then for increasing and decreasing, remember we're describing when is y increasing, when is y decreasing, but we have to do it in terms of x. So from left to right here y is going down. When is y going down? From -infinity all the way to when x equals 4. So we're decreasing from -infinity to 4, and then we're increasing from 4 to infinity. So the other thing I want to point out, for the range, this is inclusive because y can actually equal -7, all right? That is a value where y exists. For increasing and decreasing, we use parentheses because on the turning point, that is not considered increasing and it is not considered decreasing, okay? So on the turning point, you would not include the value of x.